Hello everybody. The video of the week will be about roof systems. In the last video we have talked about the structural systems of roofs, and we focus this term about the timber structured roofs. So in the previous video we have learned the technical terms, which are studs, purlins. How many different purlins do we have? Sub, mid and ridge. We have talked about rafters, and we have told that, or I have told that, these three studs, purlins or rafters are acting as the main structural components of the roof systems. And in order to increase the strength of the roof, especially against lateral loads, and in order to increase the durability maybe of the roof systems, we need to tie all these pieces to each other with collar ties. And in order to help the purlins, especially span passing purlins, mid and ridge passes span, we add some braces, which we call as angle brace. Very simply, what do we have? We have a floor, and we are going to make our roof system being carried by this floor. You please remember that floors are being carried by columns. Usually I use what type of floor system? In order to make you understand the subjects, I use reinforced concrete slab floor. But it doesn't matter if it is reinforced concrete, one-way rib, two-way rib, hollow slab, or even flat slab. We are going to have columns, and we are going to have a horizontal plane made of reinforced concrete being carried by columns and mostly beams. And on top of these type of span passing and load bearing floors, we place sub purlins. We are talking about it very schematically. We place ridge purlin, and as ridge purlin cannot fly in the air, we put a ridge purlin on top. If the distance between sub and ridge purlin is larger than 2.5 meters, we add a mid purlin here and another mid purlin there. And of course mid purlins cannot fly in the air, that's why we are going to support them with studs as well. Now that we have got purlins ready, we are going to place our rafters on top of our purlins, standing like these. And we extend usually the rafters slightly out of our building in order to make an eave. And now we are going to have collar tie here. That collar tie is going to tie two rafters, one purlin and one stud to each other. Let's put another collar tie here and one more there. And now the structural system will be finished, but let's not forget the angle brace that we will place here. Remember me acting as a stud. The purlin is passing on top of my head. I'm raising my arms and holding the purlin, passing over my head, and reducing the weight coming onto my head, and reducing the span that the purlin is passing by the help of angle braces. Is there anyone who remember the size of these members? Okay, the rafters are 5 by 10. The purlins are 10 by 10 in section size. The angle brace is also 5 by 10. And the collar ties are also 5 by 10. Okay, so on top of the rafters, we do not have a plane yet. We do not have a roof plane, which will be covered by a roofing material. Okay, it is just a frame now. And like we do in frame walls, we need to cover the side, this time just one side, the top side of the rafters, with a board which we call as a roofing board. The board, the plane which is going to carry the roofing material, roofing board. Oh, sorry, let's not forget a D. Okay, now we are ready. We are ready for what? We are ready for introducing a new subject. Okay, we are ready for looking at the layers. Layers of a pitched roof. Okay, let's see. First of all, please everybody try to remember the meaning of the word performance. What is the meaning of the word performance? Okay, performance approach or designing building elements, detailed designing building elements with a performance approach is very crucial because it shows us what user requirements are going to be meted with the space that our building elements is limiting, is bordering. Okay, we are looking at the user requirements and we are deciding what kind of behaviors should we expect from our building element. Okay, so the meaning of the performance word is the behavior of an object under environmental and usage conditions. So what kind of behaviors? Okay, this B is important, that's why I'm going to write it. Behavior. The behavior of an object. Okay, what kind of behaviors should we expect from a pitched roof? It depends on the attic space. Okay, if we want to use the attic space, it is not going to be a very proper functional place. We do not have too much space there because there are many structural components, studs, collar ties, angle braces, which is covering a space inside the attic space and decreasing the usable area. But anyway, we can choose to use the attic space as a functional room. In that case, we will expect our roof system to have a water-related performance, moisture also, moisture-related performance, and as it will be a usable space, we will expect it to have a thermal performance as well. Okay, and also we want it to look good. We want it to be durable. We want it to be, what else can we think about it? These are all, I guess. Okay, so I'm going to draw a large scale of this corner point. Okay, this is my corner, this is the corner point of my floor, column and beam in the background. Okay, and here is my sub-purlin, and the rafter is passing above it like this, let's say. Okay, and this is the roofing board. Okay, let's earn some space. Okay, I'm going to erase these. And write it back here. Okay, so firstly, what will we do? We are going to place the thermal insulation. Let's place it. Okay, so if we want to use the attic space, okay, what we need to do, we need to hold here 22 degrees summer winter. If it is 2 degrees Celsius outside in winter conditions, or if it is 35 degrees Celsius in summer conditions. Okay, so in order to prevent that temperature difference, to generate a heat flow from inside to outside in winter conditions and outside to inside in summer conditions, we need to use a thermal insulation. And we have already a good place for the thermal insulation to be placed, okay, and it will be right here, okay, like this. Okay, so in between the rafters we have a space, don't we? Yes, we have. Okay, so what we can do, we can use that space for placing our thermal insulation. Okay, and this is possible because the thermal conductivity of wood is low, which means that the rafters are not going to act as a thermal bridge. If the rafters, if we turn the structural system of the roof to steel, from timber to steel, then it will not be a good place for the thermal insulation to be placed, because the thermal conductivity of steel is higher than timber. Okay, and now what do? We have left a space between the thermal insulation, let's draw a line here, between the thermal insulation and the roofing board. That is for moisture related performance, because what will I do? Firstly, there will be a okay, so now we need to remember that there is a very important rule between the building elements. Performances should be continuous. Okay, what do I try to mean? There is a thermal performance demonstration here, and there will be a thermal performance demonstration in the external as well. So probably we are going to have a thermal insulation coming from here. So that thermal insulation and this thermal insulation needs to come and, if possible, touch to each other. So what I will do is I'm going to extend this thermal insulation material until somewhere here. Okay, and give it a possibility for making them touch to each other. Let's end it there. That's enough. Okay, and now air in between the rafters is going to enter here, and it's going to pass all the way to top, and it will be possible for that air to go out and reach back to the atmosphere from under the ridge part of the roof. Okay, and that airflow is going to make it sure that the thermal insulation is going to stay dry, and the possible moisture penetrating into it is not going to condensate and make your thermal insulation get wet. Okay, so it's going to better the moisture related performance of it. Okay, but still we don't want too much moisture to pass there. Okay, we don't want our building element, we don't want to put our building element into risk. Okay, that's why I'm going to place here a vapor barrier. Okay, I'm going to place there a vapor barrier. And now from here, if we look to the lower face of our roof structure, we are going to see either thermal insulation or rafters, but as they are all covered by a vapor barrier, you will mostly see that vapor barrier. So in order to hide it there, I'm going to cover the bottom of the tank with a wooden board again, like that. Okay, and I'm going to turn that wooden board to here also. Okay, now I have got a closed space here in the attic place. Okay, and now I am ready to cover my roof with a roofing material, but before doing that, I want to increase the water related performance of my roof. Firstly, please remember that first barrier against water in roof systems is the water proof, not proofing, but proofing material. Excuse me, so sorry. First barrier against water is the roofing material. Okay, so we are going to use a material on top of the roofing board, and that material will not let rainwater to pass. But we don't want to believe in just that material. That's why we are going to cover the top of our roofing board firstly with waterproofing. Okay, and now that that waterproofing needs to be a special type of waterproofing as well. It will be a permeable membrane. Okay, let's write the name of the layers firstly. Okay, let's write them with a different color. Okay, so this is a timber board. We are going to paint it, baby. Okay, it is the finishing surface. Behind that, we have a vapor barrier. Beneath the vapor barrier, we have the thermal insulation. What's the thickness of timber board? Let's say 2 centimeters. Vapor barrier is so thin that let's not write a thickness for it. Thermal insulation, let's make it 7 centimeters. And thermal insulation is standing in between the rafters. That's why, in order to make people understand that we place it between the rafters, let's write it. Rafters height are 10 centimeters. That's why here we have a ventilation space of of 3 centimeters. Okay, and then here we have the roofing board. Let's write it. Board. Again, let's write that it's 2 centimeters in thickness. And above the roofing board, what do we have? We have got permeable membrane, a waterproofing membrane, which is going to let water vapor, which will not, but if reaches to there, it will be dried away. Okay, and it is again very thin. vapor barrier and permeable membrane. They are kind of textile fibers. This is a flash span high density polyethylene fiber. And this is just a polyethylene foil. Okay, let's write it. Polyethylene foil. Okay, this is a high density flash span polyethylene fiber. I'm going to shoot later in this summer videos explaining these materials. Okay, now we are ready to cover our roof with a roofing material. Let's draw the schematic view of a roof tile. So it is something like this. Of course, they have a thickness. Okay, this is what a roof tile is. Okay, so and in section, I'm going to draw a section passing from here, and I'm going to look to this side. We are going to see a detail like this, and this is this part of it. Okay, this is in elevation, and this is in. Okay. I didn't draw it very well. Just a second. I'm going to draw it like this. Okay, in the side, we are going to see it like this. Okay, these are the channeled parts. Okay, in elevation, and this is the section passing from there. The hatched part is a section of it. Okay, so I mean there are fingers like these. Okay, because we are going to place our roof tile on top of a plane. So if that roof tile is just a single kind of sheet, kind of leaf, it's going to flow, or not flow, it's going to slide down. We don't want that. We want our roof system to stay there. We want to mechanically stop it. In order to do that, we place here these types of buttons. Those buttons are going to prevent our roof tiles to slide down. Because, let's place one more here. Because we are going to place it like this. Okay, it's going to go on like that. Now, these are preventing the roof tiles to go down, to slide down like this. Okay, those are just buttons. Okay, and of course the buttons are nailed probably or screwed to the roofing board. Okay, and also we nail the roof tiles. Nailing is not very usable in old or poor quality of tiles or clay tiles. In concrete tiles it's possible, but better than that, what we do with a wire, steel wire, we tie the roof tiles to the buttons. But that's the subject of a different time. I'm not going to explain it in detail. That's pretty detailed and a complex subject. We will talk about it later. Okay, but before placing these tiles, don't forget that we are firstly going to place under the permeable membrane permeable membrane a gutter like this. And we don't want people to see our thermal insulation. It's a mess here. We use here again a board. Okay, and we use here a board as well. Okay, so we surround the eave entirely with a wooden board. Okay, and we open a hole and we tie our gutter to a downspout. Okay, this is gutter and this is downspout. Let's raise this eye here. Okay, and don't forget to draw this line as well. The gutter has a closed end. If you do not put it there, all the water will flow to ground from there. Okay. What do we have here? We have got roofing button and we have got clay roof tiles here. Once more, clay roof tiles anchored to buttons. We have got permeable membrane waterproofing. We have got roofing board. We have got ventilation space. We have got thermal insulation in between the rafters. We have got vapor barrier and we have got a wood board. Okay, this is the end of the video. I'm going to shoot a video about terrace floors and I'm going to shoot a video about the internal division systems as well. Don't forget to watch them also. See you later.